Hi guys, we are now on to lesson 3, exponent rules. So we did it in prerequisites, right? We did some quick exponent rules, but the focus really was where the base was a number, okay? So I want to transfer it a little bit more with some variables and coefficients like you're seeing in like number 7 or number 5, okay? Which obviously by looking at this, the numbers are wrong. Okay, we'll deal with that in a second because we're missing number 6. Anyway, okay, so we've got the basics, which we did already. We did almost exactly like this in the prerequisites, right? So if I want an exponential notation and there's 4 3s, let's do a cool color. Let's do my favorite purple. We're going to do 3 to the 4th, right? And if you have to evaluate that, which means that you have to take 3 times 3 times 3 times 3. One of the things that I want to remind you of is that chunking piece. Don't do 3 times 3 is 9, and then 3 times 9 is 27, and then you go 27 times 3. Oh boy, I don't remember. Chunk it. 3 times 3. 3 times 3. 81, right? So instead of doing 3 times 3, I mean, obviously, again, you have your calculator, but like, just if you didn't have your calculator and that quick math, that's kind of what I want to keep you with that, is that quick math. 2 to the 5th. That means that there are 1, 2, 3, 4, 5 2s. And if I were to do 2 to the 5th on my calculator really quick, that would be 32. 2/3 times 2/3, if I want to write it as an exponent, that means there are 2 of those. And if I want to actually evaluate, I would distribute this power to both. So 2 times 2 is 4. 3 times 3, or 3 squared, is 9. -5, and make sure that you are using parentheses. I can't say this enough. We're going to start playing a little bit more with those calculators. I got mine plugged in now. We're going to be using them a little bit more frequently. If you don't bring yours to school, please do bring it every day. But if you don't, you got to make sure you're using parentheses. If you were to type -5 times -5 or -5, if you were to type this in your calculator, I misspoke. If I were to type that in my calculator right now, I'd end up with -25, okay? Which is true. But that's because in this case, the 5 is being squared and the negative's kind of coming along for the ride. This is really what they're saying. They really mean -5 times -5, which is a negative times a negative, positive, is 25. We'll start playing around a little bit more, like I said. Okay, so the 2 rules that you learned. 0 exponent rule. You learned anything to the 0 power is 1. And you also learned that anything to a negative power, let's say -2, is a reciprocal, right? I said the word reciprocal, right? Put it over 1, and then you flip it. But why? Why is that? You just taking my word for it? Let's actually learn why, okay? Let's start up at the top here. So I know 3 cubed means 3 times 3 times 3, 27. 3 to the 2nd is 3 times 3 is 9, right? 3 to the 1st is 3, okay? And I'm going to stop there, right? How do I look at these numbers and figure out, how do I go from 27 to 9 or 9 to 3? Aren't I dividing out a 3? Like I am actually losing a 3. Instead of 3 cubed, now I got 3 squared, which means I'm dividing out 1 3 at a time, okay? So if I want to go from 27 down to 9, I would do 27 divided by 3. I'd get 9. And then you're going to do it again. 9 divided by 3. Let me actually do this. 9 divided by 3 gives me 3, right? What's 3? Because again, I'm going to drop a 3 every time. 3 divided by 3 gives me 1. 1 divided by 3 is 1/3. 1/3 divided by 3. Think of the math here. So when I do this, I got 1/3. When you do a fraction divided by a number, a fraction divided by a fraction, you've heard keep, switch, flip. Keep the first one, switch the division to multiplication, and then you're going to flip this, and I've got 1/9. Okay, now how did that, now the shortcut is, okay, if I see a negative, I put it over 1, I bring it to the bottom, which is 3 squared, and 3 squared equals 1/9. So you don't have to do that division every time. Like to go to the next piece, I would do 1/9 divided by 3 again. You don't need to do all that. Bring it to the denominator, right? And 3 to the third is 127. So that's why when I say to you, anything to the 0 power is 1, that's it right there. That's why. Okay? Because you're dividing out a 3 every time when you lower the exponent. Okay. So let's use some of these rules with some variables now in a mix. Okay? So these first 3, nothing new. Anything to the 0 power is 1. Anything with an exponent of negative, we put it over 1 and we flip it. Right? And you can leave it like that. I don't need 25 squared, 625. I don't need that right now. I just want you to work on like the actual, the methods of the exponent rules. Again, there's another negative, put it over 1, keep the parentheses, and that becomes cubed. Okay? Try the next one. What would you do with that? It is already a fraction, so it's already made into something that I can do the reciprocal of, right? So wouldn't I just flip it? And then that negative exponent becomes a positive. Do not drop this negative inside. Like it doesn't change the value of the base. The base is a negative base. What changes is the negative in the exponent. Okay? And then we get dicey. 5, 7, and 8. We lost 6 somewhere. We lost 6. This is just how it is sometimes, kids. Moving at 1,000,000 miles per hour, and we lost a number. Okay, 5's a little different. Okay, I'm going to put this over 1, but remember, the 3 is not what's raised to a -5. The x, okay, let me see if I can. The x is raised to a -5. That is the only thing that should move down to the denominator, not the 3. Do not mistake this. That's how you simplify it, or use the exponent rules to make it look prettier. Okay? All right, so now I got a 4 times an x to the -3 times a y to the 0 power. You look at them separately. I don't want to move the 4. The 4 actually has a power of 1. It's a single 4. Okay, the x has a negative exponent. I'm going to bring that down to the denominator to make it positive because we don't want negative exponents. And that y to the 0 power turns to 1, and so it's like really like 4 times 1. Because remember, you're multiplying 4 times x to the -3 times y to the 0. So then your final answer will just be that. Okay. Now I got it on the flip side. What if it's on the denominator? Then I just bring it up. I'm just going to move that up. Like so. All right. And you can put it over 1. Like what's left on the bottom? A 1. Just like if I had, actually let me do it this way. If I had it w to the -4, right, put it over 1, then when I go to bring it down, there's a 1 that's placeholder. So it would be, in this case, this would be divided by 1, but you don't have to write it. All right, doing okay, hopefully? Okay, let's try another rule. So multiplication rule, we talked about, we went over with our little prerequisite, right? But we're going to add some spice to it here. We're going to add some coefficients. Oh gosh, I hope I numbered these right. 1, 2, 3, 4, 1, 2, 3. Oh yeah, good. Good number, good. 1, 2, 3. Perfect. Okay, but we're going to add some coefficients. So when you do this multiplication rule for exponents, I've got some steps. It says, well, first of all, it says bases must be the same. You multiply the coefficients, and then you add the exponents of like bases, right? Make sure that you know that that's only with like bases. Okay, so no problema, let's do this. The base to this one is y. They both have y, so I'm going to do just like we did before. We're going to add. The base to this one is a -2. I'm going to add -3 and 6 is 3. The base to this one is a 3. It's got a 3 to the first. 3 plus 1, or yeah, 1 plus 3 is 4. Base doesn't change. Base does not change. And then a 2 plus, so you think of it like this way, a 2 plus a -4, which is really just a 2 minus 4, because I don't like this plus minus junk, right? This really just means 2 minus 4 when I put them together. Is a -2, but you know Mrs. Reese, she doesn't like negatives. We're going to bring it down. Okay? Now we're going to twist it up a little bit more for you guys. Now I got coefficients. What's a coefficient? It's that number that's attached to the variable, right? It's multiplying to the variable. Remember the steps. Coming up here, multiply the coefficients first, and then add the exponents of like bases. 2 times 3 is 6. And we both have n's, so 5 plus 2 plus -2, or 5 minus 2 is 3. Boom, that's it. It's not as hard as it looks. It really isn't. Okay, how about 2? I've got coefficient times a coefficient times a coefficient. Then I've got -3 times 5 is -15 times 2 is -30. And then I have bases of x, so I'm going to add every single exponent with. 7 plus 1 minus 4, right? Plus -4 minus 4, same thing. So I got 7 plus 1 is 8, minus 4 is 4. Okay. What about this one coming here for 3? Oh boy, look at this. I got 8 to the 0 power. Well, that's just going to be 1, and it's 7 times 1, which is just going to be 7, right? So that's easy. Coefficients first. Well, now this is a constant, right? But I'm multiplying. So I still do 3 times 7 is 21, a to the -5th. And I don't like negative exponents. So did I say that in the directions? A lot of times they'll say only positive exponents, but you can pretty much assume, bring this down, is that you are always going to give me my answers with positive exponents, okay? So again, the 21 stays on the top, and I'm going to do divided by a to the 5th. Oh my Lord, look at 4. Not hard. You got this. Coefficients first. I got a 5 times a 2 times an 8 times a -1 times a 1. All right? 5 times 2 is 10 times 8 is 80 times -1 is -80 times 1 is still -80. And then take one variable at a time and do the variables in alphabetical order. So right now I've got W's and Z's. So I've got a W here and a W here. So W times a W means to add the exponents would be W squared, right? And then the Z's. So then I've got Z to the second plus, or times Z to the -5, so 2 minus 5, times Z to the third plus 3. So I've got 2 minus 5 is -3 plus 3. Well, that's Z to the 0 power. So anything to the 0 power turns to 1. You can pretty much just cross that out because it's going to be a 1. And there's my answer. All right, last but not least, distributed property. Here we go. You're going to do just like what we've been doing. Coefficients first, multiply, add exponents of like bases. 3x squared times -5 is -15x to the second. Okay, you try the last two. I'm pretty sure that you got this down now. And if you're struggling a little bit with any of it, you know where to reach me. But I'm thinking that this is Probably not too difficult for you guys, for my honors crew. So you should be okay. But if there's anything that gives you snafu, either, and if it's like just something minor, then wait and we will see each other. This lesson's going in on Friday for cohort A. Cohort B, it's Wednesday, so I'll see you the next day. The next time we have class, it'll be not virtual, it'll be live, so you can always circle some of your potential problems and we can go over them in class. Okay? All right. Take care, guys. See you soon.